So here's the all-seeing eye. You can look at your dollar bills, and the eye is kind of cool. So I thought I'd try to draw that for y'all. Trying to give you an idea of stuff. I actually printed this off so I can work with a piece of paper. I'm just recording, kids. You ain't gotta listen to me. So I'm going to focus on the eye. Now this eye is not an ellipse. It looks kind of like a lemon. It's two parabolas, one that opens down and one that opens up. I guess I'll start with there on those parabolas. I should only have to write one equation, then I should be able to flip a sign and maybe a little more, but it won't be too hard. But the parabola, this top parabola, has a center at 0, 2. Not center, vertex at 0, 2. And I'm going to pick a nice point on it. I'm going to pick a point over here. It's not going to be perfect, but I can get really close. It looks like it's at about -8/10. And we'll say 1.65. You didn't see anything I was writing, did you? Not a bit. I'm just going to set up the equation here. It's an up-down parabola, so I got to square x. And I can plug stuff in. Where I see h, I'll plug in a 0. Where I see k, I'll plug in a 2. And where I see x, I'll plug in a -8/10. And where I see y, I'll plug in 1.65, and I'll just go with it. So -0.8 minus a 0 squared is 4p. Then I have y minus k, 1.65 minus 2. This is going to be a -8/10 squared, which should be 0.64. And we'll have 4p times -0.35. So I'm going to my little TI off to the side here. I'm just doing the math. I'm going to check myself on the 8/10 squared because I'm having that kind of day. 4 times -0.35. Divide that 64/100ths by -1.4. I actually feel like putting that as a fraction. P is -16/35. Now, that should give me an equation that when I go back to Desmos lines up pretty darn good with that. If not, I'll tweak it a little bit. But it should be pretty good. I'll just have to control it. So that was x minus 0 all squared, or just x squared. If you've got to write x minus 0 all squared, then just write it. Equal to 4p at a p-value of -16/35. And I wrote this wrong, didn't I? Yeah, that's right. Then I have y minus 2. That wasn't too bad. Wasn't perfect, but it wasn't too bad. I'm actually going to keep it. I don't know, I might restrict it a little better. Might be that point I didn't pick wasn't the best point. Kind of makes me want to play with it again. Yeah, see, I picked 0.8. And apparently when I was looking at my paper, 0.8's not actually on there. I should have picked 0.7. So I'm going to go back to that piece of paper and redo the math with 0.7. So I'm going to put a 0.7 there. That makes this 0.49. I'm just going to go back to my calculator and redo it. 0.49 divided by -1.4, -35/100ths, which is a much better fraction. You could keep it -7/20ths. So that probably lines up a little better. Switch back over to Desmos. Yeah, it's much better. I like that a lot better. Now, the second parabola is going to be almost the same. It starts here. So it's still at x minus 0 squared. You don't have to say x minus 0 squared, kids. You can say x squared equal to 4. It's going to have the same p-value. Instead of p being negative to open down, it's going to be positive. So we're going to say 7/20. And you just got to pick the right starting place. That's kind of a, notice up here I picked about the middle. I'm going to do the same thing down here. Try and pick about the middle, and I might have to fudge that a little bit. But 1.2 to 1.4 means we're counting by 500, so this would be 1.25, 1.3. It's somewhere between 1.3 and 1.35, so we'll just cut that in half. Y minus 1.325. That wasn't bad. I'm actually going to go with that. That was actually pretty good. That's going to give me the outside of the eye. I've just got a control on domain. Both these parabolas need to be drawn from this x value to that x value. So from negative 0.6874 to positive 0.6874. I think I can remember that. Negative 0.6874 to positive 6.874. By the way, the all-seeing eye is a Masonic symbol. If you're into conspiracy theorists, also commonly associated with the Illuminati. I like a good conspiracy myself. So that draws the outside of the eye. The inside, I see basically what we call concentric circles. I don't know if you see them, but I see them. I see a whole bunch of concentric circles. And I might have to fudge this circle a little bit to get it to touch this parabola nice. I might have to. That's going to be kind of interesting to do. This was 1.325. The real question is, where's the center? Center is probably about right here. I would say the center is the center of that middle circle. So 1.65, 1.7, 758. I think it's about right there. What is that? 1.255, 1.675. The question is, what's its radius? I lost track of the x-axis here. What's the x-axis counting by? The x-axis is counting by 500ths. 0.5, 0.1. Well, I don't even know why I care about that. The x value is 0. So we have a y value about 1.75 and x value is 0. That's an easy circle to draw. That's going to be x to the second power plus y minus 1.75 to the second. That has to equal the radius. And the x-axis is counting by 2/10. So that's 2/10. That's 4/10. We'll go with 4/10 squared. 0.4 squared. It's not a horrible fit. One thing I do want to do though is I want to drop it down some. I want to drop it down because I want it to touch this bottom parabola. So I don't have the center quite right. So I'm going to play around with the center and see, maybe it was negative 1.7, too far. 0.72, that's pretty close. That's pretty much it. I'm going to go with that, 1.73 squared. And then I'm going to restrict that circle. So this circle needs to be drawn on y values from 1.33 to up here, 1.9085. And I'm going to restrict y, and that should do the job. A restriction on x wouldn't do it. But all I care about is the height, really. I want to throw away this top piece. So I'm going to restrict it from 1.33 to 1.9085. And I'm going to write that down on a piece of paper because I'll forget it. Be helpful if I put the y in there. There we go. So now we get to focus on some other cool things. There's another circle in here that has to be drawn. There's actually a couple of circles that have to be drawn. We throw away parts of them. I'm going to draw this center circle here. It should have the same exact center as the outer circle, which I settle on to be 1.73. Just going to have a different radius. So I'll figure out its radius. Now the x-axis was counting by 2/10 again. I scrolled down earlier and saw that. So its radius would be 0.2 squared, maybe a little more, but 0.2 is pretty close. This isn't going to be perfect. I'm going to bump that radius up just a little bit. All right, I'm good with that. And there's only part of that circle I don't want. And before I cut this arc out right here, what I'm going to do is I'm going to write this equation in so I can see where they intersect at. So I have some nice clean points to cut out. So this circle appears to have a center at negative 1/10 and 1.85. Very close to it anyways. So that's x minus a negative 10th, so plus 0.1 to the second power plus y minus, what did I say on that one? 1.85 to the second. And its radius is a little over a tenth. It's probably half the other one, so 0.11 to the second. Pretty good fit. Probably need to move it down just a touch, but it's a pretty good fit, and I'm going to go with it. Now what I have is I have some nice points here. Those are two very important points to me. I'm going to throw away what am I going to throw away on this one? Some ones like these always bug me. I'm going to go back to the original circle. On the original circle, I want to throw away this stuff right here. And that's going to be a two-part process. I can tell you that right now. It's a two-part process, and those are a pain in the butt. It's even going to be a two-part process to throw away just this arc on the red circle. Another pain in the butt. But it is what it is. So let me jot these numbers down on a piece of paper so I have them. Then I'll get back to you. wonder why Desmo slagged that one. Oh. Well, there you go. Finish? Really? That's disappointing. Anyways, it looks like I ran out of time. But the fun part here, I'm out of time, kids, I'm sorry. The fun part here, you're probably going to have to write both equations for the circles twice and kind of piece them together to create what you want. But, this was just to give you a gist of how you might do this. And don't forget there's also this other concentric circle right here that has to be drawn too. That's the all-seeing eye. It's kind of interesting. Might play with it. Hope you learned something. Enjoy your break or whenever it is, whatever you're doing right now. Hope you like the double chin, bad angle.